lesson. Okay, the recording is in progress. Welcome to all of those of you that are learning at home. We are too short in our second hour, so two of you will be watching this video along with the rest of your class. So class, just go ahead and say hello.
Hi.
Okay, so let's go ahead and we're going to be talking about those graphs that we were working with Tom and his 10 different stories and making sense of it. I kind of paid attention to your questions that you were asking or that you were fumbling upon, or maybe you didn't even know they were a question, but that was what was blocking you from understanding this. So for those of you that are learning at home, I invited my students here at class, if they would like to take notes on this anchor chart, they can do so, and you may do so as well, because there are some good stuff. There's some good stuff here. On the graph, now the only thing that's going to be a problem for those of you learning at home is I have the graph. It's being shown over here. Let's see if I can get it. Hang on. There it is on the TV screen. We're going to just be focusing on this one for right now. Okay. Oh gosh, now we gotta get this back. Okay, Colton, you can get back up. You're good. So that's the graph we will be working with. I guess what I could do to help us, for those of us that are learning at home, it basically looks like this. And I guess if you're taking notes, this might be a good thing to put in your notes as well. So this was just one of them I grabbed. It had a lot of things going on in here, but the one question that kept coming up over and over and over again was we didn't know where home was. So when we're looking at the graph, whichever graph you want to look at, we had no idea where home was. This was distance from home, and this is our time. Okay, so this is a classic example of a distance time graph. So the distance from home versus the time that Tom is doing whatever activity he's doing. So who can answer the question? Where is home on this graph?
At the bottom,
Yeah, very
right where
fun.
the line starts.
Right here?
And
And it just
throughout the
means
time, there,
Zero.
like 0 on Y.
Ah, I like that. If you did not hear that, Gabe said 0 on the y-axis, because if you are 0 distance from home, where are you?
0 distance from
You're at
home.
home.
You are at home. So anywhere along this x-axis is where the distance is 0. So where is home? We could put that it is along the x-axis. Or how do I want to say this? Where the distance, is 0. Okay, now this is kind of important, knowing where home is, because that's going to end up helping you figure out these graphs. Did they start at home? Did they go back home? Whatever the scenario may be. Okay. Now, on all of the graphs, we had these things happening. We had diagonal lines that went up. We had diagonal lines that went down, and we had lines that just were totally flat. They were horizontal. Do we know what these mean as far as the story? Now, remember, we're going distance from home and time. So what does a diagonal line going upward from left to right? Remember, for a graph, we always read from left to right. So this would be going upward. What does that mean? And we actually have one right here. What does that mean in the story? Right. Okay. So in case you didn't hear that, that means he is getting farther from home. Or we could say he's going away from home. Do I need to draw arrows so that we keep track of these? Maybe so. Okay, what does it mean if the line is going in a downward slope or diagonal from left to right? What does that mean for the story?
It's still like going time wise, but it's going back to where you started.
So he's going
Go back.
towards home. If he reaches down here on the x-axis, he actually made it home. So he is going towards home. If it looks like this. Huh. So what does it mean if it is just a horizontal line? And we actually have one right here stuck in the middle of the graph. What does that mean?
He's the same distance from home. He isn't moving.
Ah, he isn't moving. He has, but you are correct. He is the same distance from home this whole time. He's not going towards it. He's not going away from it. He's
Not moving.
not moving. Or we could say he is stopped. Okay. We just dissected the graph a little bit better than what we were doing last Thursday. Now we have a little bit better understanding of what's going on here. I heard just a couple people talk about this, about speed. Okay, there were some scenarios where Tom was walking, and there were some scenarios where he was running. Okay, so we probably need to get a pretty good idea of how is speed shown in this graph. If we look at these two, I hope you guys can see it. This one looks like this. This one's here. Which one would you say he is going faster?
The top one.
Colton,
Top one,
why?
because it's like shooting up, not really straight, but in a more sloped manner.
Okay,
it's
so
like
this
going
one
farther away
is,
at a very high
It's
speed.
getting higher in a shorter amount of time.
Yeah.
so more distance in a shorter amount of time. Is that what you mean by more higher?
Yeah.
So he is faster because we have more distance versus less time. Okay. So this one is slower then
Yes.
because,
It takes more time to get it away from there.
so we have less distance then. Do I just switch this around then?
Mhm.
Less distance with more time. This is bringing to mind a lesson we've already done. When did we talk about speed? Do you guys remember what lesson were we in? Oh, was it, the base runner, the guy stealing second base? Did we talk about speed?
Mhm.
Does anybody remember that equation that's going to fit so nicely with the distance time graph to finding speed? Do you remember what that equation is?
I'm trying to make up one. On my work now.
Distance and time were a part of it. Does that help ring any bells?
Didn't Mr. Nick come in and explain it?
He did. He was in here at one point. No one remembers? Okay, this is a good one to get down here. Where do I want to put it though? I did not leave space. We'll just go ahead and put it here. It was distance equals R times T. So distance equals rate, which is my speed, times time. So here's the thing. We know the distance and we know the time on these graphs. So if I want to solve this, I can, let me just rewrite it. Distance equals rate times time. I can divide by, no, I want to divide by T. I can divide by time. So if I take the distance and I divide it by the time, which is exactly what you were telling me. You said more distance in less amount of time. If I take the amount of distance divided by the time it takes, I'm going to get the speed. So all of that is right here in this teeny tiny little graph. So we're back to our distance equals rate times time. And we're going to be able to use that from now and probably several weeks down the road. Okay. So for those of you learning at home, since I know there is a bunch of you now, if you have any questions on this, please just email me. I will definitely get back to you. I will also try to take a picture of this to post as well with the video. So that way, your notes can be as complete as the ones that we made today. So signing off.